Hello, this video is going to talk about calculating um, units of measure and converting units of measure. So we can indeed change from one unit of measure to another using conversion factors. So we're just going to jump into an example. Our goal is to change 600 inches into feet. So we set up our conversion factor. Start with what you're given, 600 inches over 1. We'd like to get to feet as our end goal, which means we have to cancel off this inches, so it has to go on the denominator of the second fraction. Then we have to use what we know. There are 12 inches in 1 foot. And now we can multiply straight across, so we have 600 divided by 12, which gives us 50 feet, because this inch cancels with that inch. Similar problem, 8 hours, we want to change that into minutes. So again, we start with 8 hours over 1. Our goal is to cancel off this hour label, so it has to go in the denominator of the second fraction. And then what we're looking for goes in the numerator. So we know 1 hour is 60 minutes. Multiply straight across, 8 hours is 480 minutes. This one gets a little more complicated. We're going to change square yards to square inches. We still start with what our first fraction comes with what we started with, or what we're given. And then in this case, we have 2 yards. We have a yard times a yard. So I have to have 2 fractions in order to cancel off that squared term. Our goal is to get to inches. We know that there are 36 inches in 1 yard. So I do this fraction 2 times to cancel off my yard squared, but then that also ensures that I get inches squared to my final answer. So we would have 42 times 36 times 36 gives us 54,432 square inches. Please, you guys work through this problem, changing 3,000 seconds into hours. We're going to look at another example where we have more than one label. So we have 50 feet per second, and we want to change to miles per hour. So again, start with 50 feet per second. This time we have 1 second on the denominator because we have a label in the denominator. Then we have to choose to either change feet to mile or seconds to hours first. It doesn't matter the order. So I went ahead and changed feet to mile. Again, to cancel off feet, I have to have feet in the denominator of the second fraction. What we're looking for goes in the numerator. We know there's 5,280 feet in 1 mile. So this takes care of the miles part. Now we need to cancel this seconds and turn it into hours. Well, again, this time our seconds is in the denominator, so to cancel that label, we have to put seconds in the numerator. 1 hour is 3,600 seconds. We get that from taking 60 seconds per minute times 60 minutes per hour. When you multiply 50 times 3,600 and divide by 5,280, we get roughly 34.09. So I just rounded that down to 34 miles per hour. Okay, we're going to shift gears a little bit. We're going to talk about the accuracy of something. So accuracy just means how closely a measurement is to the actual value. And we're going to become accurate using significant digits, which just refers to that precision and accuracy. So I have a few rules for our significant digits. I call these sig digs. So if you hear me say that, that's what it means. It stands for significant digits. But when we're looking at a number and having to realize or decide what is significant, we have 4 rules to follow. So any non-zero digit will always be significant. So if I give you the number 325.6, every single one of those numbers is significant. Therefore, there are 4 significant digits. Okay, if we have zeros between significant digits, then those zeros are significant. So the 5, 3, and the 9 are all significant, and the zeros between are also due to this rule. Therefore, we have 6 sig digs. Leading zeros, however, are not significant. So leading just means in front of any other number. So all 4 of these zeros don't mean anything as far as significant digits go. So we only have 2 sig digs. And lastly, any zero after the last non-zero digit to the right of the decimal will be significant. So here these leading zeros are not significant due to the third rule. The 1 and the 8 are, and then this fourth rule says that these two zeros after that 8 are significant because they're to the right of the decimal point. So there are 4 significant digits. The 1, 8, and then the 0 and 0 are all significant. So you guys tell me, how many significant digits does 13,005.6 have? All right, and lastly, we have a few rules when we go to operate with significant digits. So if we're adding some decimals or subtracting decimals, we have to follow this rule. Our answer must have the same number of decimal places as the measurement with the fewest amount of decimal places. Similarly, when we multiply and divide, our answer has to have the same number of significant digits this time as a measurement with the fewest sig digs. So let's do an adding and subtracting example, and then you should be able to figure out the multiply and divide. I have all 3 of these numbers we need to add together. So when I add them together, I get 12.375. When we go to round, though, we have to decide, according to this rule, what should I round to? So we're looking for the measurement with the fewest decimal places. Well, that has 2 decimals, 3 decimals, 1 decimal. So this is our fewest decimal places. That's what our answer has to be rounded to, is 1 decimal. So we take 12.375 and round it up to 12.4 for our final answer.